Hello everyone. Let us see regenerative braking. Regenerative braking has the motor run as a generator. As the result, the kinetic energy of the motor is converted into electrical energy and returned to the supply. Then regeneration takes place when back EMF becomes greater than supply voltage V. This happens when the overhauling load acts as a prime mover and drive the machine as a generator. Then the direction of armature current and armature torque is reversed and the speed falls until EB becomes less than V. During slowing down of the motor, power is returned to the line which may be used for supplying another train on the upgrade motion, thereby relieving the power supply house a part of its load. This method is used when the load on the motor has overhauling characteristics as motor, the lowering of the case of the highest or downgrade motion of electric train. From the characteristics curve, it is clear that higher the armature circuit resistance, the higher is the speed at which the motor has to run for a given braking torque. This regenerative braking has some advantages. The kinetic energy converted to electrical energy which can be usefully utilized or returned to supply mains. Then having energy efficiency increases. It has some disadvantages that or need a set of battery bank to store the regenerated energy. Battery bank is must to store the regenerated energy. Load forces capable to accelerate the motor which is greater than the no load rated speed. Then braking characteristics of three-phase induction motor. It has three classification: rheostatic or dynamic braking, plucking, and also regenerative braking. First, we have to see a rheostatic or dynamic braking. This braking says the dynamic is employed to brake a non-reverse drive. A starter is disconnected from the three-phase AC mains and DC current is fed into the stator via two of its terminal. That means some of dynamic or rheostatic braking can expose their level. Their DC supply is usually obtained from a rectifier fed via low voltage high current transformer. So this is non-reversing drives. That time only the three-phase AC mains and a DC current fed into the stator via two of its terminal. This dynamic braking has some advantages. Handling this dynamic braking is very easily. Next we have to see plucking or counter current or reverse current braking. Plucking method give a more amount of braking than dynamic braking method because in three-phase induction motor the direction of rotating magnetic field depends on the phase sequence of the three-phase supply. That supply fed to the stator winding. The direction of torque developed in the rotor is in the same direction as that of the rotating magnetic field. Therefore, in order to develop braking torque in a direction opposite to the movement of the shaft, it is just enough if we change the order of phase sequence of the three-phase supply fed to stator. The circuit connection for this method of braking is very easily because the plugging circuit having clockwise and anti-clockwise of three-phase motoring and plugging operation. Then regenerative braking. This is the most economical method of braking. During regenerative braking, the induction motor is made to operate as an induction generator. It is converting the acquired mechanical energy into electrical energy and feeding it back to the supply mains. It is worthwhile to mention that when rotor of induction motor is made to rotate at a speed greater than synchronous speed, supersynchronous speed induction motor will now behave as inductor generator. The three-phase power equation or P equal to root 3 VL IL cos pi, where pi angle between VL and IL. The induction machine acts as a motor pi less than 90 degree. Induction machine acts as a generator having of flux is 90 degree greater. When motor of an induction motor runs faster than the stator field, that means synchronous speed, speed then slip becomes negative. Now, machine acts as a generator, overhauling load, hoist load and crane or downhill motion has a tendency to run the rotor above the synchronous speed. Regenerative braking is also possible with the pole changing method and by varying the supply frequency. The supply frequency or NS equal to 120 F by P. Thank you.